Hello, physical scientists. Ms. Getz here. Today we are going to talk all about the life cycle of stars. And so first, I'm going to walk you through the beginning life cycles of stars, how stars are born and live their lives. And then you are going to do a little bit of reading about how stars die. And there's actually a lot of different ways that stars die, and you'll be reading about some of those after watching this video. As we go through our video, you are going to want to pause every so often and fill in your stellar life cycle chart. So as we go, I'll talk about the nebular phase, and you want to take a moment after I finish talking about it and go to fill in your chart. So you want to write in a few details about the phase at that point in a star's life and draw a picture to help remember that phase. Throughout today, we'll talk about how it is that stars form, what makes a star actually a star, and you will learn about how do stars die in the reading that's also attached to this assignment. So we're going to start off with the beginning of a star's life. And I've placed a little pretend star here just to help you keep track of where we are. So we want to learn, how do stars form? And so stars form or are born with quotation marks because they're not technically alive, but we can kind of think about them that way, in nebulae, or a nebula would be the singular of that. And so in a nebula, gravity causes the gas that's in the nebula to clump and squish together. And as it squishes and squishes and squishes together, it gets hotter and more dense. And this is called gravitational collapse. It forms these things called protostars inside of these nebulae. And like here in this one, this is the Orion Nebula, which is in the Sword of Orion right here. So this is a picture of the constellation of Orion, Betelgeuse, Rigel, and the Belt. And then this is the Sword of Orion. With a telescope in the Twin Cities, you can actually see the Orion Nebula in the wintertime. We do at the Harding telescope sometimes. But this has 4 little baby stars in here we can't quite see, and lots of gas and dust that are slowly grouping together and will form more baby stars, more protostars. So this is the nebular phase. So the key points here you want to make sure to write down is that gravity is making gases clump together, and that they heat up and get more dense inside of these nebula. And these are all different nebula where stars are in different points of formation. So then we move forward to the protostar phase. You should have paused the video, pause if you need to, and jot down your information about the nebular phase of a star's formation, its birth, essentially. And we're going to move on to its protostar phase, essentially when the star is a baby. It's not yet a real star. It can't take care of itself yet. So protostars are hot and dense, and the gravitational collapse, that force of gravity pulling the gas together, keeps on happening. It keeps squishing it together. And protostars, they do glow a little bit because they are hot, so they glow in infrared light, but they're not yet real stars. A cool thing that does happen during this phase of a star's life is planet formation. So as a star is forming, it's actually not just a star forming, but a whole disk of gas and dust start sort of grouping together and rotating together. And it becomes a disk, kind of like you can think of it the way a person tosses a pizza crust. So you actually toss the pizza crust and rotate it to make it fling out further apart. If you rotate something, it will fling out further apart and flatten. And that's what happens in planetary formation. The picture I had earlier was a real picture. This is a simulation of how, as the planets start to form, you can see that the dust lanes clear up. That's actually gravity clumping the planets together, making them form around this protostar. And so the protostar starts getting some planets formed around it. So you might be wondering, why isn't this protostar a real star? And that's what we're going to answer next when we look at the next phase of stars. But you want to make sure to jot down on your notes sheet that protostars are baby stars. They are hot and dense and glow in infrared light, and gravity keeps on pulling them together. You might add something else like "and planets form at this time," just so that you remember, yes, this is when we get planets in a solar system. So why aren't protostars real stars? Well, let's figure out what makes a star a star. So a protostar becomes a real star when they begin to fuse elements. They begin nuclear fusion. And fusion is when atoms combine together to form larger elements. And that releases the energy that causes stars to glow, that causes stars to shine so very brightly. So fusion is this process of two atoms coming together and their nucleus, the center of the atom, fusing, sticking together to a bigger nucleus. So here there's two particles, here there's three particles, and they collide together, they get squished together, and now we have four particles. So it's a larger element. A larger atom is formed from two smaller atoms. And then you also notice that in this fusion process, this little simulation shows, there's this radiant ring of like yellow. It says 3.5 MeVs. What that 3.5 MeV stands for is how much energy is released by this reaction, this nuclear reaction that happens inside of stars. So this nuclear fusion releases energy inside the core of a star, and that energy radiates outwards and is what causes the star to glow so brightly that we can see them and that they light up our whole universe and create light here and energy here on Earth. So that is what makes a star a star. It goes through nuclear fusion. And so stars that are going through nuclear fusion live in the main sequence. And the main sequence is the phase of the star where, again, they're going through this nuclear fusion and they're burning hydrogen into helium and other larger elements. And this part of a star's life is the longest, and it lasts from millions to billions of years, depending on what type of star it is. There are different classes of stars. You can see the different colors and sizes. This is not a real photo. This is a real photo of our sun, the nearest star to us. But in this main sequence phase, the key ideas are that we have nuclear fusion happening, and that's when hydrogen gets smushed together into larger elements. And it's the part of a star's life that is the longest. It's kind of like adult life for humans. It's the longest part of a star's life. There's this special chart astronomers use that plots the temperatures of stars versus their brightnesses. But the main sequence is this line along here. You can see there's lots of dots. And it's because most stars that we see in the sky are living their lives just like normally, chilling out in the main sequence. That's why it's named the main sequence. Astronomers aren't very creative sometimes. And so as this happens in the main sequence, stars have balanced forces. And they don't change very much over all the time that they're in the main sequence. The pull of gravity inwards, that gravitational collapse that was squishing them together before, becomes balanced out by the push outwards of the energy of fusion, of that nuclear fusion, that reaction causing energy in the core of the star. And this balance is called hydrostatic equilibrium. You don't have to know that word, but it's kind of a cool word. Again, it's hydrostatic equilibrium. And it just is telling us that during this time, the forces are balanced in a star. So it's very stable, it lives for a very long time, and it's going through nuclear fusion in its core the whole time, here in the main sequence. So make sure to pause and go jot down about the main sequence, add in some sort of picture to help you remember that it lives most of its life here, maybe something about the forces being balanced. Then we're going to move on to the next phase of life of a star that all stars go through. And that is a giant. It's the red giant phase of the star. And so we're going to talk a little bit about that. So the main sequence, that's most of a star's life. If we were to scale this picture according to how much time a star spends in each part, the main sequence would actually be almost the whole piece of paper, because that's the majority of the star's life. But the red giant phase is actually a pretty big piece as well. So the red giant phase is the beginning of stars dying. When stars run out of hydrogen in their core and they start fusing larger atoms, this balance of fusion and gravity changes. The forces are no longer balanced, and that causes them to expand and actually cool off. So a star becomes cooler as it dies. It expands outwards, and it becomes a red giant, or another color giant, but most often it's a red giant. So we call it the red giant phase. So our sun will eventually expand outwards to be a red giant star. And you can see that the smallest red giant and the largest red giant, they're like both a lot bigger than the sun. So when the sun starts to die a few billion years from now, it will expand outwards into a red giant. And in the red giant phase, you can see again, expands outwards. This is a little animation I thought you might enjoy. It might envelop some of the planets. You can see that this animation is showing this star enveloping some of the planets, so they get kind of burned up inside of the sun. Not so great. A little worried about Earth. But during this phase, the star really expands outwards. It starts fusing some heavier elements inside of its core, and you get different types of elements being fused. But eventually, it runs out of elements it can fuse. And that's when the star really starts to die. And so you are going to read about the different possibilities for the ways that stars can die in the reading that's attached to this assignment. And the different possibilities are that it can go have a planetary nebula form of it and create a little white dwarf inside it. Or, so this is for sort of medium to small stars, if you have a large star, it will go supernova, and then you get a neutron star if it's just a large star. Or if it goes supernova and it's a very large star, extra large, we'll end up with a black hole. And so you want to do your reading to keep track of these different ways that stars die, their different endings, a white dwarf, a neutron star, and a black hole. And again, just like you did while watching this video, jot down some notes on your notes sheet and a little sketch that helps you remember that phase. Thanks, guys.